Hello, Algebra 2. Here we are with 8.4, Day 1, Graphing Rational Functions. A rational function is one function divided by another. If you remember back to your rational numbers, when we were talking about classifying numbers in a much earlier math class, rational numbers were the set of all numbers that could be written as a fraction. 1/3, 5/6, 7/9, anything that can be written as a fraction. 5/1, still a fraction, still a rational number. So any function that can be written as a fraction is going to be a rational function. And we're going to have f of x equals a of x over b of x. Sometimes you'll see that as n of x for numerator over d of x for denominator. F of x will have a vertical asymptote whenever b of x equals 0. We cannot have the denominator part equaling 0. And when that does equal 0, or where that would equal 0, that's where we get our vertical asymptotes. Only possible to have one horizontal asymptote or none at all. Pretty key point here coming up. If the degree of the top, or the biggest exponent on the top, is bigger than the bottom, b of x, then there is no horizontal asymptote. Okay, what would that look like? Let's say we had something with x to the third on the top, plus 2x squared minus 8 over x plus 1. Okay, the top has an x to the third, which is bigger than x to the first, so no horizontal asymptote. If the degree on the bottom, b of x, is bigger than a of x, the HA, or horizontal asymptote, will be 0. Let's just say that was flipped. Okay? Now the x to the third is on the bottom, much bigger than x to the first. Okay? So when we have the bigger exponent on the bottom, the bottom, or the denominator, is going to be growing faster. It's going to be getting bigger faster than the numerator is. And when you're dividing by bigger and bigger numbers, what happens? Okay, 1 divided by 2 is 0.5. 1 divided by 10 is 0.1. 1 divided by 100 is 0.01. We're going to get really, really, really small decimals, and eventually it's basically 0. So that's why we have our horizontal asymptote at 0. If the degree of a of x equals b of x, the top equals the bottom. If it's a tie, then we divide the leading coefficients. Let's say we had 6x to the third plus blah, 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 blah over 2x to the third plus blah, 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 blah. Okay? We have x to the third and x to the third. It's a tie. Then we look at the leading coefficients. 6 over 2 would be 3 for our horizontal asymptote. Would be 3. What about over here? We got 3 examples here. 2x to the third plus 1 over 3x to the third plus 2. We have a tie, so we divide 2/3. 2x squared on top, x to the first on the bottom. X squared is bigger, and it's on the top, so we have no horizontal asymptote. Over here on the right, the last one, 3x to the third on the bottom. The bottom's going to have a bigger denominator, so we get just knocked down to 0. Y equals 0 is going to be your horizontal asymptote. Backside. Let's see if we can look at these and come up with the asymptotes, vertical and horizontal. Sorry that it flip-flopped here. I don't know what was going on. So remember, vertical asymptotes come from when the bottom would be 0. So 1 would make this denominator 0. So our vertical asymptote would happen at x equals 1. Horizontal asymptote, the top is bigger, x to the third, so no horizontal asymptote. Middle one, x plus 1 over x squared minus x minus 6. Ooh, let's factor that. X minus 3, x plus 2. So what would make the bottom equal 0? 3 and negative 2. So our verticals are going to be at 3 and at negative 2. Our horizontal asymptote, x to the first on the top, x squared on the bottom. Good thing I didn't black this out. I can still see it. Bottom wins, and if the bottom wins, it just gets pulled down to 0. Third one, let's have you push pause and give that one a go on your own. Welcome back. X minus 3 on the bottom, we cannot have 3. So that's where our vertical asymptote is, 3. Horizontal asymptote, we got a tie, 2x to the first on top, x to the first on the bottom. When it's a tie, we compare the coefficients. And this is really a 1x. So we have 2 over 1 for just 2. All right. Let's get into graphing it for reals. Okay. F of x equals 2x over x minus 3. Okay. It's very similar to our last problem we just did. Our vertical asymptote is going to be at 3. Horizontal asymptote, we have a tie, 2x over 1x, so our horizontal asymptote is 2. Let's get these asymptotes on the graph. Vertical asymptote, vertical, up and down, crosses the x-axis at 3. So it's going to cross the x-axis at 3. 1, 2, 3. Okay? And this is going to be a dotted line. Another way to think about it is x is locked in at 3. Doesn't say anything about the y's here. I can have 3, 7, 3, 1, 3, negative 2, 3, anything. So that's why it's going up and down. My horizontal asymptote, we got y equals 2. Okay, that's a horizontal line crossing the y-axis at 2. Horizontal, you think about the sunset on the horizon, that horizontal line. Okay, crosses the y-axis at 2. That means the 2 is locked in for the y's. So you can have any x you want. You can have negative 7, 2, negative 1, 2, 3, 2. Well, not 3, 2, huh? We have an asymptote there. 5, 2, 10, 2. Okay? So there's our asymptotes. Next, when we're graphing, we need 3 points on each piece of the graph. Okay, if you have a fraction bar, I would strongly recommend that. Alpha, y equals, fraction bar. Boom. Type it in just like you see it. Top part goes on the top, bottom part goes on the bottom. Okay? If your fraction bar doesn't do that for you, then we're going to need to use some parentheses. Parentheses around the top, divided by, or fraction bar, if you get the thick diagonal division sign for your fraction bar, divided by the bottom. I'm just going to roll with this one. Let's see how it looks. There we go. You can see where your vertical asymptote is at 3. Looking right there. And you can see where both of these appear to level out at about 2. Okay? So we're going to go through, and I like to just use trace. Trace. Let's work on the left side. So if my vertical asymptote is at 3, how about we start with 2? Trace 2, enter. Okay? You could use table. I like to use trace, so then I can see a picture of it on the calculator, and that helps me kind of visualize and help me make sure I'm in the right spot when I'm graphing this. So if it's a nice point, we don't need to label it, like this one, 2, negative 4, 2, 1, 2, 3, 4. If it's not a nice point, we should label it. I know it gets kind of tight on these, so you can label them off to the side if you need to. Okay, let's just keep going to the left. How about 1? 1, negative 1. And 0. We could go with 0, 0. Not that helpful, but it's our third point, and it's a nice one. What if we did negative 1? Nope. Negative 2. Nope. Negative 3. There's another nice one. Negative 3, 1. I know that's our fourth point, but that's almost more helpful because those two are basically right next to each other, and this is going to help us with our curve and flattening out right there. And then we're just going to follow the asymptotes right on out. Okay, there's our first branch. Let's work on our second one. Okay, again, if that's 3, let's go with 4. 4, 8. So we had 4, 8, 4, 1, 2, 3, 4, 5, 6, 7, 8. 5, 5. 7, 6, 5. 6, 4. Again, 6, 4 is not going to be very helpful because those are so close together. Can we get another nice one? 7 is not nice. It's 3.5. I mean, it's not terrible for writing that. 8 is 3.2. 9 is 3. There's a nice one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. You can see that's pretty nice because it gets down right close to that asymptote. Okay, sometimes you're not going to be able to just keep going and find a third one that works really nice. Sometimes you just got to use the 3 you have, and then just know that your arrows are going to follow the asymptotes right on out. But if you do have the luxury of having some free space in there that you can use, okay, it wouldn't hurt you to get one of your asymptote or get another point closer. Okay. Oh, let's talk about domain and range. Domain and range, we're going to use all the x's going to the left forever and all the x's going to the right forever. We're just not going to use one particular x. We're not going to use 3. So our domain is going to be all x's that are not 3. We can say the same thing about our y's. We're going up forever. We're going down forever. We're just not using one particular y. We're not going to use 2. So all y's that are not 2. Last one. Are you excited? This one's a little bit crazy. Just a little bit. Not too bad. Alright, if we're looking at this, x to the third minus 10 over x minus 2. X minus 2, we're going to have a vertical asymptote at 2. Horizontal asymptote, what situation do we have here? Top is bigger. So if the top's bigger, we're not going to have any vertical or horizontal asymptote. Okay, so we're going to have our vertical asymptote at 2. We didn't label them on the last one. We should have done that. X equals 3. Y equals 2. This one is x equals 2. Alright. I used fractions, or I used parentheses last time, so I'll use the fraction bar this time. Alpha y equals. We got x to the third bumped down minus 10. And then on the bottom we have x minus 2. Graph. We got a little bit of a parabola, and if we were to zoom out, so we got a parabola and then we got this crazy steep line. If we were to zoom out, that's zoom 3, enter. Okay, you're going to see how that parabola basically flattens out. Like this one looks pretty normal, and then boom, it kind of flattens out, and then next to it, right next to that asymptote, is basically a straight vertical line, and then it just kind of bends to the right afterwards. So it's kind of a weird one. We're going to do the best we can with it. If you do get a parabola one, let's go zoom 6, zoom standard. If you do get a parabola one, it's always good to get the minimum or maximum. So let's start there. It's been a while since we did this. Second, trace. We want a minimum. We have a low point on this one. So remember, we get our little cursor, a little Spider-Man dude, a little as close as we can to the bottom. And then we do left bound, left, 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 left. Go back down to the bottom. So you had to undo those 3 or 4 left clicks. Now right bound, we're going to go 3 or 4 right clicks. And back down to the bottom. Okay, this one we will need to write down. We got negative 1.1, comma 3.7. Negative 1.1, 3.7. Alright, let's see if we have any other nice points. How about at just negative 1? Nope. 0. 0, comma 5. Always nice to use the nice points if we can. 1 and 1, comma 9. Sometimes you just can't. If you can, fantastic. Ooh, we didn't get any on the left side of this parabola. Let's do a couple, even though we already have our 3 points, let's do a couple on this side. That was negative 1.1. If we do like 3, graph, trace, 3. 317, whew! Negative 3, Mr. Handke. 7.4, that's not terrible. Negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7.4. We probably could have played around and found another nice one, but just not about that right now. It is 10:59 p.m., and this is the second time through this video because the computer went to sleep in the middle of the last one, and I didn't see it right away and continued talking. So, recorded almost the whole video there without it actually saving, because when the computer goes to sleep, the camera stops recording. That's fun. Okay, so that's just the left branch. Okay, we're going to do the best we can with this super steep thing over here. We just know it's basically riding next to the vertical asymptote right here, and then it does start to slowly go out. I'm not sure how much of that we're going to be able to fit on our graph. So sometimes with something crazy like this, just do the best you can. Let's see, so we're at 2, so how about like 2.1? 2.1, it's negative 7.4. comma negative 7.4. What about like 3? 3 is going to be 17, so we're going to have all kinds of decimals here. Let's go 2.5 is 11. 2.4. We're at 2.3. This might just be it. 2.3, comma 7.2. Alright, so this is basically a straight up and down, and then we slide out. We start curving out a little bit there. So again, crazy one like that, just do the best you can. Let's talk domain and range. Okay, we're going to use every x to the left, we're going to use every x to the right, we're just not using that x, 2. So domain, all x's that are not 2. Range, with this part, we only got down to 3.7, so we're thinking y's greater than or equal to 3.7, but then this crazy thing goes down forever and up forever and hits all the y's. So that's a bit of a weird one. It does end up being all reals, because this piece uses all reals all on its own for all the y's. Down forever and up forever. Okay, do the best you can there. The main ideas that we're focusing on really are the normal, basic, horizontal asymptote things. That's the new thing we added today. The previous lesson we had the vertical asymptote part. Today we're adding the horizontal asymptote parts. Okay, so that's the ones you basically want to focus on. Don't really get too worked up about this. If something crazy does happen on your worksheet, just do the best you can. Most of them are probably going to be like this. Remember, we want 3 points on each piece. And if they're not working out perfect, we do need to label them. All right, thanks for watching, kids. Good luck.